firstly, thanks for this opportunity to share some of my experience in learning with you, and and then I know Alvin. I can't remember how many years back lah. Yeah, somehow we catch up somewhere in NTU lah. Yeah, and I was asked to do an MBA module and also MSc module at the business school and also in the Nanyang Technopreneurship Center. And so what happened was one of the professors was teaching both design and system thinking, and he was teaching in a very engineering way. NTU full of engineering professor, right? And then, but then in the Technopreneurship Center and Business Center, we think in the business way. So, so we look at system dynamics, lesser formula, okay? So today no formula, okay? Yeah, and I think the whole idea is to have discussions and some concepts, and I try to make it applicable to your work as much as possible. Okay. All right, so the objective, as what Alvin has discussed with me, is one day intensive. It's a workshop, so therefore it's more interactive. All right, it's not seminar where I talk. Neither is a lecture, and I think there's no grade to be given. That's a joke. Okay, yeah. So I have only 3 objectives. One is the approach and framework. Okay. How do we approach system thinking? This is a philosophical part, lesser theory, and then the important part is then going to modeling, okay? Because how do we build model? And if you have the computer, then if every so-called table has computer, then we can go into simulation. I think it's system thinking and dynamics, because it's dynamics. So it's extremely complex, and using algorithm cannot solve the problem most of the time. So we have to do a lot of simulation. The good thing about simulation is that it can step it through, and step by steps. It can step dynamically, means through time. So it's not statics, but you need to use software in order to see the full picture. It's like a dashboard lah. When you're driving, where each road am I, what's the speed and whatever. And then when you step through, you can see the full picture. And then you can develop and you can modify your variables, which means your assumptions. I presume you all know what's variable, right? That's mathematics. And then we come to the human part on system design and decision making. So what we call bounded rationality, all right? Because systems still has human inputs, and you know, human is the most complex and complicated animals. I have a friend who is at JPL, Jet Propulsion Lab, who designed spacecraft, right? And it was during Obama time. He's a Singaporean, by the way, and he was supposed to design a spacecraft to moon. And he told me, you know, anytime you want to design me a machine and land it on moon, I can design. Once you put in a human being, this whole damn thing become very complicated, because the human brains is a lot of things based on judgment. All right, so therefore, most of the systems, when you inject a human element inside, or you try to solve humans' problem, you will start seeing a lot of complication, and therefore, mathematics will not solve the problem. So it will be a lot of simulation. The question is what to put in, and such that it is easy to understand. Okay, and if you are interested, we can talk about business model, because this is because system thinking and system engineering slightly different. System engineering very mathematics, automation driven. Now I study EEE in NTI. No, not NTU, NTI. So that's where we study a lot of stochastic system, feedback system. So complicated, it's all formula. But here we are looking at humans, so we look at more dynamics and decision making for human. Okay, but nowadays we tend to integrate business modeling, because a system exists by itself. The system diagram sometimes very difficult to see the full picture. It's very complicated. If you draw it, it can be as complex as, that too many loops, you also cannot see what's happening. So sometimes putting in a business model and emphasizing on only a few decision points is easier, okay? And I think it's really up to you to decide how sophisticated or complicated you are, but I probably is the first one to integrate the system dynamics into the business model. So I'm writing a book on that, okay? So I thought that would be very useful. Anyone familiar with business model canvas? Okay, that's another 2-day topic. Okay, I'll give you some very simple stuff. Okay, all right, so I step you through my background so that you can understand, and depends on what question you want to ask. So I do also social innovation. This one, not really, don't bother, yeah. So I start off as an engineer. So I have 3 roles right now, as an engineer, as an educator, and an entrepreneur. So we all engineers are very systematic and logical in our thinking. So I started off as a system engineer. The first project that I graduated work on is, I can't remember, is that a 50-person software project. Well, I was trained in Bell Lab and to write system software. So I do system simulation using, I think, about 30 vexes at the same time. If you know what are vexes. Still using, right? All the mini computers. Yeah, and then I proceed to become a product manager, regional business manager, director, mostly in new business area and planning. And I cover SD Aerospace, so I design comm system for fighter jet, which is not flying anymore. That was early days. And I think SD computer, electronics in encryption, information security. So the very first VPN in Singapore was all developed by me. I'm not sure whether it's still used in the embassy or not, but all the encryption modules are done there. Then when we move on to engineering, are mostly business, and then corporate is mostly investment. So 1991 to 2002, that's my time in ST. And so I fly, and this is what I built recently, 3 years ago. This is the first version of a flying drone. And this is what I did for US, spin-off from UCLA. And the rest, not important. Yeah, so teaching couple of overseas university, especially nowadays, I do some of the NUS stuff and teach MBA in Chinese, actually. So I speak in Chinese, but not as good as the Chinese. But the mainland Chinese doesn't want you to speak like a Chinese one, correct? So you speak Chinese, broken Chinese. Okay, yeah, and I work on, together with astronauts, he spent about 500 over days in International Space Station, and he has 5 spacewalk, and it's coming in June. So I bring him to NTU at the same time, okay? Because we are running a hackathon in NTU for rovers or robots on Moon. And so the first project I'm going to work with him is actually 3D printing of medicine in space for space travel. I already have a printer. It's just how to work in a gravity-less environment. Yeah. So those are the stuff that I work. These are some of the projects like bicycle helmet, get its best invention 2018. This together with my students. The students in Harvard. And so we did a crowdfunding, raised $3 million for the first crowdfunding project in 1 month. So understanding customer is very important to me, right? And some of the stuff, younger days become champion in entrepreneurship pitching. That means I can talk, sweet talk people. Some of the stuff that I do, you can see, mostly in healthcare. This is one of the machine that I built, complex system by itself. You can see the complexity on the left-hand side, and you build it into something very simple. So the complexity is that, okay, you have all these blood lines are connecting to the patient. So the important thing, whether it's design thinking or system thinking, is always where is your problem to be solved. So a lot of people think that, you know, things are complex, like on the left-hand side, right, is the what they call a dialysis machine that you see in NKF, right? And patient has to go 2 times a week, or no, 3 times a week, every alternate days, and then 4 hours. So the whole system is very complex. So the question is, how do you simplify it? And the way to simplify it, and a lot of people say, hey, the way I simplify it is actually take the machine, which is weigh 100 kilogram, and turn it into a 1 kilogram machine. So that's not the way to do it, okay? We need to combine sometimes design thinking with system thinking, rather than take it separate. So the design thinking approach is always focused on the customer. Who is your user, right? So when you focus on the user, then you don't, so logically when we look at the other side, we look at the user, the patient that's sitting on the bed, and normally they are not in the picture, right? Because you tend to look at system from a product point of view, and therefore you look at this and say, how can I reduce its complexity? But however, what's the purpose of this? The purpose of this is for the end user, right? Or whatever you call the customer. In your case, probably the end user. My case, I focus a lot on customer because I focus on people who pay. But the end user is critical because this is what the purpose is for. And therefore, if you understand the end user, then you understand the needs. So a lot of people say, hey, wow, engineering very good, 100 kilogram into 1 kilogram, right? But actually, the thinking is, if I focus on the end user and you say, the system is designed for what purpose? And is to bring value, right? Value to the end user, okay? I tend to look at things from the value point, V-A-L-U-E. Value means what are you value adding? So when the end user has a problem, you value add. But a lot of people will look at the cost saving, whatever, time saving. All these things is okay, but all these things can be converted to value. Time save is value add, right? Cost, yeah. But then other things that a lot of people tend to focus on all this stuff, efficiency driven rather than effectiveness driven. So, but no matter how efficient you are, if you're not effective, the efficiency is a waste of time. Okay, you must first be effective, then be efficient, right? So meet the customer needs or user needs, then reduce the cost. So you focus on the user and then you look at the value and what's the value proposition that you want to give to the user, and you find that actually it's not about the machine, right? It's about his life. So things become very simple when you look at the purpose. His life, what is his life all about? His life is about, with these systems, I cannot work, right? I cannot travel because I'm tethered to that system every 2 days. So I cannot work, cannot travel, right? So if you define it as freedom for the purpose, then it's very simple, right? If this person needs freedom, what does it mean? It means he needs to have therapy, he needs to have dialysis and he move around, and it means what? And so that he can have a life, he can have a job, he can travel, and therefore the system complexity will reduce if you focus on that. And you say, what do you require when he need to be moving around? So you start thinking you need a portable machine, and based on the portable machine, you move around, it got to be battery operated, and that's where you do a technical specification. But but normal user can always think through like that, right? You need to be move around. Move around means weight is important. 1 kilogram, 50 kilogram backpack or whatever. You start having that concept. Once you have that concept, so it's that small, lightweight, battery operated, work anytime, anywhere. So there's the 3 requirements. Once you have the 3 requirements, your system design is very, very simple already. All right, so focus on the user, okay? And once you focus on the user, you'll find that all the complexity is gone. And finally, we designed a machine that is just 1 kilogram, fully automated, fully battery operated. But of course, you have to do the trade-off. You cannot do a 24-hour machine. in the earlier, because technology doesn't support it at the point in time. So you do a technology trade-off, and so it's a 6 hours cartridge changes, all right? But the concept is there, and then you can move on from there, all right? So my job is always to make system more simple, right? But engineers like to make the system complicated. Because you know what engineers like to do? For example, where's the controller? Oh yeah, like this controller, right? Think. Is this very complicated? Yes, all right? And then I've done programming, you have done programming. If we need to find one function, what do we do? We don't need to add extra function. Therefore, I need to have, now a lot of controllers have Netflix. So we want to access Netflix, what we do? We add a Netflix button, right? Then a YouTube button. Then suddenly you have 50 buttons. Think about your application. That's what you do. You keep adding, right? But actually, do you use it? All the buttons? That's it. Actually, when I come in, I only do something called power on and off. The rest I never use. So what's the purpose of all these things? Correct? And we tend to make system complicated by wherever the user want a requirement, just add. You complain, add. But you never think about actually the user complaint is what I call a causal factor, right? Where's the cause? Right? The cause could be simpler. And if you go in and look at the system at the cause, you will find that most of the time your remote control, right, is power on off, volumes up down, and then channel up down. That's about it. You only need probably one trackball to do only. You don't need all this complication. So you can, all right? Of course, from a technology angle, I'll say, forget about all these things, right? Turn this into Siri and done. I don't even have a hardware. But engineers just love to plug buttons after buttons. And so when you do a system design, think through. When people ask, am I adding another button to the remote control? Okay? Or you should try to simplify it. Okay, so this is how we add in, and this is a graph analyzer machine. Doesn't matter. This is most recent one, and yeah, those are the complicated stuff that I work on that turns into a therapeutic machine for stroke patient. And this is the latest I work on, which is 3D printing of medicine. All right, so we use 3D printing to print the white layer is medicine, the orange layer is vitamin. No use one, but it sustains the release. So now what we did is create one pill that can last for 7 days. Again, is the system. If you look at the system of this, is the system of what we call drug compliance. Drug compliance means doctor prescribes you, insurance pay, and then you and then you take the medicine. You must take 7 days, right? Antibiotics, let's say antibiotics, 7 days, 3 times, or maybe 3 times a day, or 1 time a day, and we can compress everything down to 1. So the dream is 1. So we work on alternative technology to bring that pill from 7 days, 3 times to 1 pill. So you take a pill, your antibiotics are done. Remember when you're having flu, they prescribe you antibiotics, 3 days, you stay at home, MC finish, you come back, you've forgotten about your medicine. Because you're well, so-called well, right? Yeah, so those are the things that we make system as simple as possible. Okay? And I think if you think like engineers, engineers tend to make system as complicated as possible. This is our training, we keep on adding stuff. Okay? Yeah. All right. So that's about it. I have probably around 10 projects running at any one time. Okay. The traditional way of looking at system or traditional thinking is straight through, and this is what we always do, right? We in software we like to decompose, and when they decompose, we subroutine down, right? And we subroutine down, so it's actually very straight through linear thinking, which is good, easy to understand, all right? But that is our software development. But in the real world, you have feedback coming from all kinds of places, and then you have The system thinking is to model the real world as much as possible, but the gist of the real world, okay? So it's not as simple as traditional thinking. Now, this is what you're going to do later. You're going to start drawing, okay? At least apply some of the principles. So it's complicated, right? But never mind, we will go through the simple stuff. And what I'm trying to do is to put the business model inside so that you do not just see the what you call the diagram, the loops and all these things. It's very complicated. But if we are able to put it into our daily work, the business model. Now, business model doesn't mean it must be a business, right? It can be, not necessarily it must revenue and cost. It can be cost-benefit analysis, correct? So when you put in your own business model, you're much more holistic. So you plug in that, and that allows you to see the full picture of the front end and the back end and how they interact. Else, when you start looking at traditional system thinking picture, you sometimes do not know where's the front end and the back end, okay? Because this is already very simple, all right? You can see very, very complicated stuff. So system thinking, first thing is holistic, all right? Must see everything as a whole. And then the other thing is causal. Who caused what? And I think the fishbone chart, all this that you all learn or you all know is good enough, right? But then causal factor and correlation are also completely different. And sometimes we mistake correlation with causal factor. And that can be disastrous in your implementation. All right? So system thinking helps you to do that correctly. And then the dynamic perspective, which is important, the time-based thing, right? So I'm not going to go through this, right? VUCA, this standard stuff, huh? So let's look at a holistic perspective, right? This is the standard thing, whether you are looking at the forest or the trees, okay? And this is also something that everybody learned, right, from primary school, right? If you look at one picture, you see one small component. So system thinking give you the whole picture. The question then is, how do you know it's a system? How do you test the system? Okay, so the first thing is purpose. You must know what's the purpose. That's why I say the dialysis. You don't just look at the machine. First is, what's the purpose? The purpose is looking at the patient, keep him alive, and let him have freedom. Or sometimes I just simply say, return the life back to him. That's the purpose, right? Not to reduce the machine from 100 kilogram to 1 kilogram. That's not the purpose. The purpose is to enable the life of the patient. So I think the purpose is a higher plane, and sometimes you need to be careful, right, when you define the problems. And then after that are the elements, right? So the elements are things that exist in the system. So what's the element, right? You need a machine, you need an interconnection to link everything together, right? So I think the simplest way is actually to look at this, right? So I built this graph, and this is my first version, right? This is what you call urban version, which is for like air taxi type stuff, and this is the Ferrari version. This is for tourists, okay? And I'm building the third version. Now, so from a system point of view, right? Inventor perspective, entrepreneur's perspective, and policy maker perspective, we can have some small system to big system. So anybody want to? Yeah, now very difficult talk. Anyone want to give comments? Or maybe the way is simple is you work together, right, in your group, right? Then just draw a picture. What is important is the system of system. That means when you try to identify something, you try to identify the basics of the system. Then you, for example, from entrepreneur's perspective and the policy perspective is different. The holistic view is different, right? And from my perspective, I'm the inventor. So maybe we can look at how to cascade. And when we look at one system, who are the stakeholders? Can we do it this way? So maybe what we can do is inventor perspective, who are the stakeholders? Entrepreneur's perspective, who are the stakeholders? And policymakers, who are the stakeholders? And then we can draw the picture. This stakeholder play what role in that system? Can? Just mental exercise. Just discussion to get you moving, okay? It's a hierarchy of system, basically, yeah. But the stakeholders in each systems are completely different.
So we want one table to talk about 3 different perspectives.
Yeah, you can just have one draw picture at 3 different levels. At each different level, who are the stakeholders? Who are the people who are going to make decisions? Who are going to be people who are involved? Yeah. This is a very simple way of getting your mind thinking about system. So when I was designing the craft, so from the inventor perspective, right, I need to know what system I'm operating in. So it's actually quite simple, right? The purpose is to build a craft. What kind of craft? Something that is user-friendly, easy to fly, at certain speed, and safe, right? So once you define the purpose, then where are the elements? The elements is firstly the craft design itself, the safety, then the engineers, right, and the suppliers, and the prototyping. So it's a very, very small system. The focus and the purpose is building the craft. But you know that the navigation systems, these are technical stuff, right? The safety, everything has to think together. We have to think about how high you fly, so that because it's small craft, there's not much of a safety mechanism. So how do you if you fall, how, put airbag, like car airbag, rather than have wings to fly. So those are the very simple perspective, right? So when you expand up to, let's say, from me as an inventor go to become entrepreneur, running the business, then I need to know basically where I'm going to fly, which market which customer segment, and I need to know which country, I need to know who are the investor and everything. So the stakeholders increase. But it's a different group of people, and it's the profit and loss comes into picture. And that's your variables, all right? The first few variables in inventors will be speed, safety, blah, blah. Business will be profit, investment, cash flow, everything. And then when it comes to policymaker, it's a bigger one. There, where's your insurance, airspace, government, right? Now, we know that our system is building into space, right? Because during the recent air show 2024, they say a helicopter is going to fly. Yeah, they're going to fly. They charge you $300 per flight for 15 minutes, maybe. But yeah, it's affordable or not? So the whole system perspective. So you need to know which level you go in. It's a hierarchical thing. So when you design system, you need to know your system boundary. What problem you solve, you draw where your boundary, you solve the purpose in the boundary, and then certain people will look at bigger system and look at the different boundary. For example, if I look at a policymaker's boundary perspective in Singapore, this thing won't fly because it's risk averse, right? So I would rather go to US and fly, where the boundary is much bigger, where the law is very clear. In Singapore, there's still no law. They say 2024, but it's going to be, I think it's going to be just pilot, right? But if you go to US, it's like commercial on the spot. Okay, so you need to know which systems, which boundary, define a boundary, and then you decide where you go. All right, this is a very simple example, right? So eventually, that's the whole system we are looking at, and yeah. Now, let's move on to the causal perspective. So holistic means looking at everything and then from different boundaries of the systems. Then we look at the causal perspective, right? So this is very important because when you do system thinking, you start seeing all these arrows, okay? Yeah. So source A causes B, not a problem, very easy, okay? So A is the source, B is the consequences, right? It's the result of A happening, okay? And therefore, this is easy to understand. Now, we have add complexity, we put a plus. Positive means same direction. Okay, so if A increases, the cost A increase, B will increase. If A reduces, B will reduce. Simple, right? Okay. How do we apply? Okay, the more goods you sold, the higher the sales. Correct? It's a positive, same direction. So it's plus. Okay? Now, so for an example, in your work, can be customers, can be employee satisfaction, can be workload, whatever, can be requests. With A causes B in the same direction. In the same direction means if A, right, workload increase, what happened? Workload increase. What happened? B, what happened? Think about it. Now, sales is easy lah. Sales is easy. Sales increase. I mean, goods sold increase, sales increase, right? But there are some that go it's positively reinforced. Okay, the more workload you pile on me, what it is? Is it a positive? Or the happier you are? Oh, okay. That's why Alvin is here. Okay, think about it, draw, and then we can have a discussion, right? This is the fundamental of causal relationship. Okay? Plus is not always like moving up. The plus means can go down, right? It's same direction. That's all I'm trying to tell you, okay? Yeah. So the negative is the opposite direction, which I would not ask you to do exercise. So the negative opposite direction, if A increase, B reduce. If A reduce, B increases. Okay? So the example is cost, right? Cost increase, profit drop. So this increase, this drop. If cost reduce, profit increase. It's the opposite direction, right? So the output and the input for negative sign is opposite direction. For positive sign, it's the same direction. It's either this way or this way. That means now it's this way or this way. And if it's negative, then it's this way. If this go this way, or this way. All right? That's all. Okay? You need to understand this. Don't make things too complicated. Huh? All right, so no exercise. Okay, now fill the blank. We're trying to do modeling. So the basic part you need to understand, because you want to do the price elasticity is a complex model, okay? So this is just simple, okay? Simple modeling, right? Okay, now this one. This one is, just now I'm just going you a linear. Now is linking them together. How you link them together? 5 factors. Okay? Yeah. Draw arrow from one to another and say it's plus or minus. This is the answer, right? Right? So if you coal power will increase carbon emission, result in climate change, right? And then green energy is solar, reduce carbon emission, right? And then nuclear power, of course, reduce carbon emission. Now, what's the purpose of this exercise is this, right? The purpose is when you are trying to model the system, you need to understand what are you modeling. So you need to firstly identify, let's say I'm modeling climate change. I need to know what's the important thing, carbon emission, result in climate change, right? Then what causes carbon emission, all this stuff. So I need to know all the variables. So don't worry that in the first place you don't identify all, but the key variables you must identify. And then once you identify the variables, then you must now know how they link to each other. What's the causal relationship? So the first step is you want to solve a problem. That problem, what are the variables? What are the key variables that you want to define? And then the next thing, find out the causal relationship. And that's how we start linking. Okay? Yeah. And that group is like, their mind move faster than mine. Yeah. Okay. Okay. Now you have to think a little bit further. Besides linking, you must have to think what are the collateral things that can possibly happen. So I ask you to say, I give you that key variables, and you got to create a new category. What will happen if that I never take care of? Okay, yeah. Identify a new category.
Foreign labor.
Foreign labor, correct. Yeah, foreign labor, sorry. Yeah. So the B and L actually interchange. Okay, look, don't think too complicated. Everything is dealing with numbers. Okay. Just numbers, right? We are modeling the numbers of people in a locality, let's say in Singapore, right? That's all. So identify a category which I've never factored in. That's all.
You mean another
Yeah, is that new immigrants? What is the new category that should be in there? In the boundary. Okay, let's say you are in Singapore, the boundary of Singapore population, right? comprising of what I can identify and what else I never take care of.
War.
Crisis. But that's not a number. Crisis is not a number. No, a new category that has a number. Foreign labor is a number, contribute to the population, right? Yeah. This all deals with numbers. I'm modeling the population changes. Illegal immigrant. Good. Yeah, this is. So some factor will create new factor. I'm not saying that you're wrong, right? I'm just saying create a new category. So a lot of people say foreign workers, then you never consider the family of foreign workers, which could be times 3, you know. Minimum will be about times 2, times 3, right? So that is a thing that we seldom never look at the variable and the impact that will create another variables. Okay, so this is one way, right? Just to enhance your thinking. Okay, now we know the causal factor already, right? Then we go into the dynamics, right? So these are events, things are getting more complicated, but not to worry. So system, there's no right answer. So we want to actually establish the causal relationship because we have time elements and then variables can come in at any time. So there are always feedback and the group always use a lot of feedback. So I can see already. So their mind moves very, very fast. So purpose is important. So the issue is that when you start doing system design, you have too many variables. So is this variable very important in that purpose, right? So go back to the purpose first. And then what we want to do is have dynamic design, which is time-based. It keeps changing, but it's stable. Eventually, it will stabilize. But if you design a thing that's not stabilized, it will blow up in your face. You know, nobody can design one thing, keep on growing, until it will explode. Right? So we need to, at least what that group say, right? When you reach certain thing, it must be stable. Okay. Then the structure. We'll talk about the structure and boundaries. Like the flying car, right? Where are the boundaries? Else you will start simulating all kinds of things that are outside of boundary. So you need to define your boundary well. Okay. All right. So now we go into causation versus correlation, right? So when you are trying to link up, make sure there's causation, right? So this is very simple, right? Average temperature go up, ice cream go up. Average ice cream sales go up, right? Murders also go up. Some people were, you know, it's like some people get frustrated. Not as high, but actually it can also potentially go up, right? But then some people do it. Yeah, we see this thing. Sales of ice cream go up, murders go up. That's not causation. That's correlation. So statistics ended up, you may unwittingly draw this picture. This one is really too much, right? But sometimes two things are subtle. You think they are causation, but they are correlation. Okay? So be very careful when you start doing all this stuff. Okay?